In this video, we will be discussing the peer review process and its role in scientific publications. I would like to acknowledge the traditional owners of country that I'm on today by recognising the Kaurna people and their continuing connection to land, waters and culture, and I offer my respect to their elders past, present and emerging. Now firstly, I want you to consider the types of things that impact the quality of what you know. How do you know when to believe something that you hear, see or read? Jot down your ideas and pause the video here. Now consider which aspects relate just to what you read in scientific articles. There are two main aspects that impact the quality of scientific information. The first is the quality of the inquiry. This means that the appropriate type of inquiry was undertaken to suit the question being asked. And secondly, the quality of how the information is reported. Is it communicated appropriately for the audience and have appropriate inferences been made from the data? Now, as a student, you'll probably access a range of resources to gather information every day. You could use any of these examples to find scientific information, right? But how do we know whether one is of higher quality than another? One way we can decide is by using sources that undergo the peer review process. So which of these do you think might undergo peer review? Peer review is a very narrow process that involves very specific types of work. Our gold standard in looking for high quality information would be a peer-reviewed journal article, but sometimes academic books and textbooks are also peer-reviewed. But what does that actually mean? Well, peer review is a process where articles are scrutinised by experts in the field. These experts ensure that suitable experimental design and appropriate analysis have been applied to the information presented, and they look at whether the conclusions that the authors have drawn are reasonable given the information available. The peer review process involves only primary literature. That means that it's the original source of the information, and all other information sources repeat or interpret these peer-reviewed articles. Now that sounds great, but it doesn't really tell us how the peer review process impacts on the process of doing the science itself. To understand that, we need to reflect on how science is done. The process of science is not a simple linear model where we ask a question and answer it. Rather, it is influenced along the way by the scientific community, which is why peer review is so important. Science benefits from a cooperative approach and diverse viewpoints. Most scientists work in teams, including students, and communication is integral to scientific research. The results are shared with a community of peers through seminars, publications and websites, and research papers that are vetted by colleagues through the peer review process. This allows scientists to create a vast body of knowledge together and help to maintain its accuracy. The peer review process is performed by the scientific community and has a series of roles to play that help to constantly improve the quality of the scientific information and promote ethical behaviour among the community. Peer review requires scientists act as critics by evaluating evidence and ideas that are presented to them. They must also be innovators by generating new ideas and new interpretations of data and alternate explanations. And they act as a watchdog to help eliminate bias. But overall, because of the high standards that are expected in the field, the peer review process acts as a motivator, as it provides scientists with recognition, esteem, and a legacy of their research. Now, it might seem as though the peer review process is a recent invention, but I can assure you that it's been used for several thousand years, and whilst we now have strict guidelines for how it is done, the general concept is the same. Essentially, that someone else who knows a bit about what you're talking about looks over your work and makes sure it is a reasonably accurate interpretation of knowledge. While it shared some similarities between the process now, it was once much more controlled by a small group of people, usually royalty or religious leaders. For example, the Spanish physician Michael Servetus in the 1500s was burned at the stake for suggesting that blood passed from the right side of the heart to the left, then through to the lungs. Luckily for Galileo, the Italian astronomer, by the 1600s the penalty was less severe, as he was confined to his home after publishing a book opposing the Church's view that the Earth was the centre of the universe. He described the astronomical model heliocentrism, in which the Earth and planets revolve around the Sun at the centre of the universe. But what made the process much more widely accessible was the invention of the printing press with movable type in 1939 by German inventor, printer and publisher Johann Gutenberg. This advancement meant that it was economically viable for the production of books and introduced the era of mass communication, and this was a key development in scientific revolution. Being able to produce print for the masses meant that communication was much easier, so early aspects of review began as a way to regulate what was distributed to citizens. Subjects were controlled by royalty and religious leaders who limited access to knowledge and only allowed material that was approved to be printed. Modern peer review began to appear in the mid to late 1600s with the creation of the Royal Society of London, which still exists today as an independent scientific academy of the UK dedicated to promoting excellence in science for the benefit of humanity. The Society produced its own journal called Philosophical Transactions, and initially it was only reviewed by the editor, Henry Oldenburg. By 1752, the Royal Society of London members took on the responsibility for editorial production, and these members were simply recognised as a group of knowledgeable men. But as journals grew, external reviewers became necessary, with an increasing specialisation and popularity of journal publications. The journal Science didn't have external reviewers until 1940, and the American Practitioner used an in-house peer review system until 1962. But how is this process managed? The journal Science, for example, receives up to 200 manuscripts per week and publishes one journal per week. Many other journals mainly publish once a month or a few times a year. Each week, the journal Science publishes around 5 research articles, which are considered major advances in the field, and around 10 report articles that have a broad significance to current events. So who performs all these reviews? Peer review means that it must be peers within the community, so other knowledgeable scientists. They must be familiar with the field of study, but they must not be directly involved with the research being evaluated. They may or may not know the authors, and they may be colleagues or competitors. So what do? Well, they need to consider the relevance of the article, the validity of methods and interpretations, whether the work is original and if the communication is clear. And then they must provide feedback, usually in a written form that's provided to the authors so that they can make adjustments. And the process often involves multiple iterations to ensure that the information is as accurate as possible, and this varies in the time it takes. The research component may take as little as 6 months or sometimes more than 10 years. From there, a scientist or group of scientists writes a manuscript and submits it. This might take anywhere from 6 months to a year. Then the manuscript enters the review process, and this normally takes around 2 months. If revisions and resubmission are required, and it usually is, this takes around 1 or 2 months, or maybe longer if additional experiments are suggested. Then finally, it's accepted and published around 1 or 2 months later, depending on the frequency of journal publication. But what happens when peer review isn't used? During the COVID-19 pandemic, there has been an increase in the number of publications being released that made some fantastic claims. The New York Times, for example, published research coming out of Harvard University found an association between high air pollution levels, COVID-19 infection and death, but the rate reported was 15 to 20 times stronger than past findings. The problem here is that this study had not been peer-reviewed. Therefore, other experts in the field were unable to assess the quality of the research and the validity of the results. But the peer review process does have its issues. The process is slow, and it has to be. It reflects the importance in getting it right, as the information is permanently on record once published. Confidentiality can also be problematic, as reviewers are expected to keep findings confidential, but rarely are findings completely unexpected due to the discussions amongst the scientific community that we have at conferences or when we seek funding. As a researcher, the peer review process impacts both hiring and promotion opportunities, as the number and quality of peer-reviewed publications reflects the quality of your research. And there's a hidden cost to the process, as the reviewers are not paid. Instead, experts volunteer as a recognition of their expertise, and it's estimated that approximately $3.7 billion of volunteered time is used every year. However, there's no cost to submit a manuscript to a peer-reviewed journal. And unfortunately, the process is not foolproof. between the year 2000 and 2003, Jan Hendrik Schon and his colleagues published over 25 papers on superconductivity, all of which passed through the peer review process. In 2002, Professor Lydia Son, a mechanical engineer, and Professor Paul McEwen, a physicist, raised concerns about the accuracy as the different experiments carried out under very different conditions, published in different papers, displayed the same background error. The papers were later retracted and Schon was fired due to misconduct. But retractions are very rare, and retractions due to scientific misconduct are even rarer. In an analysis of the Medline database, only 395 articles were retracted between 1982 and 2002, and this was from over 8.5 million citations. Of these retractions, 27% were classified as scientific misconduct, 62% as unintentional errors, and 11% of those retractions simply couldn't be characterised. And with any system, there's a bias, such as the type of research that tends to be published and the types of comments that different reviewers leave. The journal Nature has trialled an open system of peer review, sadly without success, as they struggled to get reasonable feedback on their submissions. So it seems that the current system is one that we're bound to until we can find a better way. In any system, there will always be someone trying to take advantage, and this is where we see predatory journals. You can see this attempt sent to me in a field that I have absolutely no experience in at all. And when we investigate further, they're asking for around $2,000 to submit an article. Predatory open access publishers charge publication fees to authors without providing editorial or peer review. Academics who publish in these journals are often from developing nations, as they're especially at risk in the pursuit of academic promotion. However, as protection, many of these journals can be found on Beall's list, which regularly update the details to help prevent this type of behaviour. So while the process of peer review might seem overwhelming, as a scientist, we must publish our research. So I look forward to seeing you in the workshop this week, where we will work through how to prepare yourself to undertake the peer review process.